right. Hello, everybody, and welcome to the stream. Hope everybody is doing okay tonight. You'll have to forgive me. I'm getting my butt kicked by allergies today, so I'm a little bit congested, and I may sneeze from time to time and or have an allergy attack. So if that happens, sorry about that. But yeah, it is what it is. So, we have a couple of things on the agenda tonight that we didn't quite get to last night to wrap up first. And then I've got an idea of another feature that we can go ahead and implement. And hopefully be able to finish up reasonably tonight. So we'll see where we kind of land on that. So before I jump into that, I do want to go ahead, of course, and take a quick second to thank the supporters of the channel. Starting with our partners, that is ARCO, Garbolis Inc., Patrick Kuhlman, and Wen Chang. They are the highest tier on Patreon and YouTube memberships. I would also like to thank all the other supporters listed here, who are the other tiers of support on Patreon, YouTube memberships, and of course, Twitch subscriptions. So thank you all very much for your support. I greatly appreciate it. In addition, I would like to thank each and every one of you who are the viewers, either here on Twitch or on YouTube when this gets uploaded to there later. Of course, without all of you guys, this project wouldn't be here, wouldn't exist, right? None of this would be possible. So thank you all very much for your support, following along, viewing, chatting with me, etc. As always, I do want to mention that this is an interactive stream, so feel free to jump into chat, and if you have any questions, I will do my best to answer them. And with all of that said, I think we can go ahead and sort of jump into what we're going to do tonight. So, couple things to note. I am trying a new terminal emulator tonight called WebSterm. I like it a lot so far. It seems to be pretty responsive. And I like how easy it is to configure. And it's GPU driven, right? So I'm going to give this a shot tonight and see how I like it, right? Trying to find a right terminal has been a bit of a thing, because they all have something that I don't like, but this one seems to tick all the boxes so far. So anyway, where we left off last night was we actually got all of our viewport stuff done and in. In fact, I will go ahead and just pull up the application so we can visually see where we left off. So we have our dual viewports here. We can load up a scene, and right now both viewports are tied to the same scene, and we can select objects using this right viewport. The left one doesn't actually do anything though, right? So that's by design, using some logic that we added to bind that input specifically to this viewport, right? So that is kind of where we left off, and what we're going to do tonight is we're going to implement multi-camera support, so that the views can use different cameras, because right now our camera system really only supports one camera, and that's the one that we're sort of just using everywhere. So we want to kind of do away with that. We do have a small change that I want to make to the material system in terms of using the frame data instead of passing a couple things individually. So our views are basically going to require a pointer to a camera to be passed to them. So that's another change we're going to make. And then we're going to go ahead and try and make a wireframe viewport. We'll call it a viewport mode, right? Or rendering mode. I guess it'll be another rendering mode that we can add to our repertoire, right? So we're going to try and make a wireframe version of that, and that will also be useful for orthographic views and things like that, which at this point will be really easy to implement because all we have to do is change the projection matrix, right? So that is a little bit of what is on the menu for tonight. And of course, all of these things are working towards us creating our editor. So with all that said, let's go ahead and close out of this, and we will click back over here to our project, and I want to do a fuzzy search on, I think it was camera system was it? Wasn't acquire. What was it? Get default, I think, is what we've been using everywhere. Yeah, so right here we can see that our render view world is using that, our render view pick is using that, our view editor world is using that, as well as our testbed is using that, which I think this is actually doing that in the initialize, which we actually don't need to be doing, so we can get rid of that. And then this one is in the update, so we don't want to be using it here either, really. And the more I think about it, the more that I think that we may not actually even need a camera system, because I'm thinking that maybe the application should probably be managing this, right? So if we actually go to our definition here, or not, okay. Camera system, let's see. So we have, I just have to refresh my memory because it's been a long time since I've touched this code. It looks like we have a hash table, I'm guessing for camera lookups by name. So we acquire a name, yeah, okay. Maybe that is kind of a nice thing to keep for now. Okay. And then all this default does is return the address of our default camera, which I think we create during the initialization phase, right? So I guess for the sake of named lookups, I guess we could keep this for now. I may not wind up keeping this in the long term, but I guess for now, that's fine. So all we need to do that is we really just need to call camera system acquire, pass it a name. If it doesn't find that name, I'm guessing it creates a new one. Yes, it does. And then updates the hash table. Otherwise, it increases the reference count. Okay. So let's go ahead and, I guess, fix some of these things. So right here in application updates, we are actually using... We're using the default camera for some reason here, and we really don't need to be doing that. We can say state world camera, right? And we want the address of that, right? Oh, and we don't need that. Incompatible pointer types. Struct camera. Is world camera a pointer? World camera is indeed a pointer. Okay, so we don't need the address of that. In fact, we don't even need this local variable, right? All we really need is this guy. So we can actually just say state world camera, state world camera, right? And get rid of that. Get default. So when we initially create our world camera in our application initialize, this is where we need to do something a little different, right? So we're just getting the default right now. We want to say camera system acquire, right? And then we're just going to call this one world. And I believe that does return a pointer to a camera. Yes, it does. Okay. So that is those ones taken care of. In fact, I'm wondering if I should actually get rid of the default camera. Nah, I'm not going to do that. I could do it, and it would force us to kind of use this model, but I'm not going to do that just yet. Okay. So the other thing that we need to do is view. Let's do view world first, and we will also just repeat our search for get default. And instead, let's see, we're doing this on register, and we're setting data world camera. We don't actually want to do this. So this actually needs to go away. So I'm going to go to definition, and I'm going to nuke this, right? Because what we actually want to do is whenever we are going to render using this view, we want to pass the camera at render time that we want to render with. And that gives us the flexibility to render with any camera. And whenever we want to reuse the view, for example, we can reuse the same exact view, just edit what camera is actually being used. So I'm going to remove that from the internal data. I'm going to remove it from here. And then world camera. Now we don't have that. So on the packet build, we are going to need to take in a camera to actually handle that now. Again, I apologize for the the sniffles. My allergies are kicking my butt tonight. So I guess what we probably need to do is head on over to render types and change the packet build to take on a camera as well. Because all views are going to have to take some sort of camera, right? And I suppose if they don't need a camera, then we can go ahead and just not provide one, right? We'll take a pointer to a camera. That way we're not sort of screwing ourselves there. So render types, let's see, packet build, and where we have struct viewports, we want to also have a struct camera pointer, and we'll call that C. And did we not update the comment for this? Tisk tisk. So we have the, oh, we didn't update this at all. That still has the frame allocator. That's bad. This should be frame data, and this should be a pointer to the current frames data. And then param, next one is v, a pointer to the viewport to be used, and then param c, a pointer to the camera to be used. And again, we're not going to maintain any sort of relationship between cameras and viewports, because those things can be interchanged quite a lot. So we don't want to sort of enforce any sort of one-to-one relationship of any kind there, right? So that means I need to go to the top and forward declare struct camera. And now I can go back to build and we'll say camera pointer C. And then down here, all I have to do is I should just be able to pass the pointer, right? So, whoops, not X, C, right? So we'll just pass that there, and then we'll be using whatever we pass in. Obviously, this means that we'll need to go to the header file as well. So view world H, and on packet build, we'll go struct camera pointer C, which means we also need to go up here, struct camera, forward declare that guy, and that should do it for that one. We'll just need to make that same change to, let's see, it was pick, which again, I know we still have to actually split this view, but because we're actually still building it right now, I actually need to implement this change here as well. So struct camera, and then struct camera pointer C, oops, need a comma, and then, oops, render view, pick C. Go to packet build, struct camera, whoops, camera C, and then right here we're using get default again, so we're going to do away with that and get rid of this to do, and change this to C, and do the same here. All right. So that should be it for that particular view. The last view we need to do is going to be which one was it? Editor world. Right, so we'll do the H file first. Struct camera. And struct camera C, whoops, comma, and world C, and we'll add the camera here, struct camera C. Right, and then here we also have internal data world camera, so we're going to need to go there. We want to nuke that one. I don't think we were doing that on the last one. We were just getting the default camera on the last view, but this one is actually storing it. So world camera, we want to delete that line. We don't need that anymore. And then the internal data world camera is just going to become C. What were we doing here? Oh, this was for the gizmo scale, which we actually still need to address. So I'm going to change the comment there, even though it's technically not being used right now, so that when I reactivate it and take a second pass at that, it's correct. Okay. Let's see, what is next? So we have that. We actually need to do the render view system. That's also going to require a change. So struct camera, packet build. And again, we're probably going to wind up getting rid of this system, but until we do, it's got to be updated, because I haven't completely decided whether or not I want to do that yet. We've not updated the comment. A pointer to the viewport to be used, and param see a pointer to the camera to be used. All right, so we need to go to the C file. So that's going to be render view system C. And again, we just have to do struct camera C. And then when we actually go to pass this through, we need to pass through the camera as well, right? Okay. The only other thing that I can think of is likely this simple scene is going to need to be updated as well. Because it calls the packet generation for the world packet. So we actually need to make sure that's updated as well. So what that means is when we actually go to populate the render packet, it also is going to need to know what the camera is. So we're going to put camera C here. And then we'll pass that through here. And then simple scene H, build, actually I think it's populate here. Yep. Struct camera C, and then that's already forward declared, so we're good. Now it should be testbed main C is now going to require that camera. Wait a minute, were we already... Did I just add that unnecessarily? Because I wasn't paying attention. Yeah, I did. It was already in there. Oh, what a dingus. Okay. Let's see. Yep, we already have current camera in there. Okay. So simple scene C. This should be current camera. And we actually don't need this. Okay. Let me build this and see if I missed anything. I did miss a couple things. Okay, so testbed main 694. Yes, so editor world. We need the... In this case, we can hard code the camera because we know which one we're going to use. So that's going to be state world camera. Whoops, that's already a pointer. We don't need the address of that. Render view system. Sorry, I've got to blow my nose really quickly. Okay. So, render view system. What did I miss there? Testbed main, too few. Oh, okay, 734. This is also going to be, oh, let's see. So this is an example of a render view that does not need a camera, right? But we still have to pass something. So in this case, we could just pass a null pointer there. Did we update the UI packet? Or the UI view? I don't think we did. Render view UI. We did not update this one, so this is going to break if we don't update it. Right, so struct camera C and struct camera, oops, if I can spell it correctly, And then we need view UI C. Okay, so we'll get this one updated as well. Struct camera C. Even though we don't actually use it, we still have to sort of match the interface on there. Okay. So test main. I think we might be good at this point. Let me... Nope, I missed one more thing. 6:55. Oh, I guess I accidentally deleted the T there. Unused variable internal data. 117 on editor world. Really, this is unused now? What does this have in it? Just a pointer to the shader in our debug locations. Really? It doesn't... Oh, that's on build. Okay. Yeah, I guess that does actually kind of make sense. Alright, so we can get rid of that. Render view world. Internal data. I thought I got all those already. View world. Nope, apparently not. Okay. So this is in the packet build, so we should have... whoops. C position. And then instead of data, let's see. This is on render. Shouldn't we have already got... So on the packet build, we do save off the view matrix, if I'm not mistaken. We do. So we don't actually even need to do this. We could just say packet view matrix, right? And we're going to take a copy of that and modify the copy. So we should be good on there. What is this to do? This is terrible. Need to bind up IID. That's what we're doing. Oh wait, why are we re-getting this shader? Don't we... Data S ID, right? We're getting the shader ID up here from the actual shader itself, and then... Why are we doing that? Right, this should just be S, or data S. Right? Get rid of that. Oh, wait a minute. What shader was that using? Render view world internal data. Has that been using the wrong shader this whole time? Can't be. Ugh. That's actually been using the wrong shader this whole time. That is using this guy, which is actually the world shader. And you know what? While we're in here, I think I'm going to fix this too, because we're doing this other nastiness here, which is kind of stupid as well. Let's go ahead and handle this like when we first crank up the shader, right? Or when we first start up the view. There's really no reason for us to be doing this otherwise. So the built-in material shader, we load it here, we unload the resource, we don't grab the shader pointer there. Here's a skybox shader, we don't grab it there either. The terrain shader's here. We don't save off any of these. We should be saving off pointers to these guys, right? And then data S is okay. I'm not sure why I did it this way. Oh, ads. About 30 seconds late on that. Sorry about that, if you can hear me. About 15 seconds left. All right, and we're back. And for those of you who are wondering about what the lads thing is about, it's because when I type !ads to trigger the Nightbot message for ads, explaining that we pause the stream so you guys don't miss stuff, somebody pointed out, or a couple people pointed out, that it looked like I typed lads, so that's what that is about. It's very funny. All right, so what we were talking about is basically we are loading up these shaders within the render view on register, but we're not actually saving pointers to them, with the exception of this one down here, which is really ass backwards, right? And we have this configuration of a custom shader name, which I don't think we're going to actually use either, so I'm not even going to bother using that. I'm not even going to bother with this check at all, right? Because this is very specific to the way that we render views in the application, or render the world in the application, rather, right? So we're going to refactor this a little bit, because data up here is only holding one shader, and then we're actually holding two shaders, I guess. So we have the skybox shader, and then we have the S, which is actually the material shader. So I'm going to rename this material shader. And then we have the skybox shader. We also have the terrain shader and color shader, right? We should be saving pointers to all these because we're doing lookups every frame, and that's really dumb, right? We shouldn't be doing that. So I'm going to refactor this to just handle that really quickly. So basically what we need to do is the same thing that we did here with the skybox shader, right? So in fact, I'm going to yank that real quick. We're talking about moving this to the material system here. I don't think I'm going to do that. I do eventually want to find somewhere else to load these, though. Like the configs doesn't really belong here. But the issue that I want to solve right now is material shader, and then this is going to be, you know what, let's actually change this name too, because we're dealing with more than one shader. Material shader name, right? Whoops. Why has it done that? Right. Why'd you do that? Material shader name. Yes, okay. And then we'll rename this as well. Material config resource. Just to make our code a little bit easier to understand as to what's going on here, right? So, we'll go ahead and save off a pointer to the material shader, right? And obviously that means this is wrong, so that needs to be material shader name, right? So now we actually have a pointer to deal with that stuff, right? Okay. So that's the material shader. We're basically going to do the same thing. We're already doing this for the skybox shader, so that's fine. The terrain shader, it needs to be done. So we'll do that here. Terrain shader, and this should be terrain shader name. Right, so we save that off, and then are we already doing this for the color shader? I don't think we are. So let's go ahead and put that here. Color shader, color, whoops, color shader, color 3D shader name. I don't think we're going to have a color 2D shader in here, so I'm not going to worry about that right now. So we don't need this stuff anymore. Instead, we are going to say data color shader, and we're going to do that here and here. This we're not going to do anymore. Ambient color, that really is still kind of relevant, but I'm not going to address that right now. Okay, so we have those, and then when we go to build, no, when we go to render the packet, rather, let's get rid of shader ID, because we shouldn't be doing that. So here we're using the shader by ID. Do we actually have... We only have use by name or ID. Be nice if we could use by a pointer too, but I guess that's not that big of a deal. All right. So that to-do can go away. And instead of doing this for the skybox shader, we can now say data skybox shader. Okay. So we bind globals, use that, apply the globals, okay. We bind the instance for the skybox. Okay, this all looks fine. That all looks fine. Okay, so we're good as far as the rest of that goes for the skybox, okay. So for the next one, here we're doing this crap again, right? So we actually don't care about any of this. what we want to do is we have data terrain shader ID, right? So we want to use by that. And again, data terrain shader ID for that. By the way, I do want to mention, in case you guys are new to the stream, this is an interactive stream. So if you guys have any questions about what I'm doing, feel free to jump in the chat and ask, right? I don't mind, you know, answering questions and whatnot, and I enjoy chatting with you guys. So feel free to jump into the chat and say hello. Okay, so we have that. And I think we should be good. We should be good with that for the terrain shader. I think that's all we need to do there. Okay, so these are static geometries, so these are going to use the material shader. So we want to say, whoops, data material shader.id, and that's going to be the same thing down here. Data material shader ID. And I think that's the only place we have to change that. I think the only reason that this was actually working is because some of our uniforms actually lined up and wound up being the same locations within the different shaders. So we were getting extremely lucky that we weren't hitting some stupid bugs, right? Okay, this is no longer a to-do. So there's that. That to-do still counts. Okay. This is no longer should go. This is goes through the same geometry system as anything else. All right. So here we are going to do away with this lookup. We don't need that. Instead, we are going to say data color shader ID. And then I think that's actually all we have to do, because all we have is globals on that one and local. So we shouldn't have to do anything other than this. So this is going to be data color shader render frame number, right? Did we miss anything? I don't think we did. Okay, so we build, so that's good. Let's debug and see if we busted anything. Should give us exactly what we had before. Okay, we obviously did break something. So what do we have here? A seg fault probably on position, I'm guessing. Why are we're seg faulting on the frustum creation? Yeah, I think the position that's being passed is rubbish. Let's see. So current camera is 0, right? It's null. Okay, so simple scene, populate render packet. State world camera. World camera is empty. So did we not? I thought we set that, didn't we? Did our acquire not work, maybe? Let's do a debug point right here. And see. Oh, I would stop this application. And relaunch. Okay, so Failed to acquire a new slot. Really? It's the first one we've done. Why did that fail? So it looks like we're exercising code that we haven't exercised before. Okay. Okay, so we have a free slot. Max count is... Oh, wait a minute. Oh, yeah, that's a nasty little bug. So, when we're doing the camera acquisition, we're iterating through the cameras, right? Looking for a free slot, right? So we're supposed to be looking through the state pointer cameras array that we set up. Oh, did we even set that up? Yeah, the state pointer cameras, which are we even... Okay, we do have memory up here for it. But, let's see. We invalidated all cameras in the array. So literally the bug is just, we're looking at the index to see if it's a valid ID, which it never will be. So what we should be looking at is state pointer cameras sub I dot ID. Okay, so if we find one, then we set the ID and we break. Check to make sure that we found one. Right, okay. Creating a new camera. We set the ID here. Create the camera. Set the hash. Okay, so that should be fixed. I didn't realize that we'd never actually exercised that code before. So that was an interesting find. Okay. So let's go ahead and run. Really? Okay, now what did I miss? Oh. Creating a new camera named S. What could possibly be the bug here? Could it be the fact that we're not, like, passing a camera name? Gee. I must have been really tired when I wrote this code. Alright. Now we have a camera. Okay. Has no rotation, no position. Well, 0 rotation, 0 position, technically. And it should have a default view matrix, identity matrix, which it does. Okay, so we should be good to go now. Right, so, yep. Okay, we can at least see the camera movement there, so we should be able to load up. All right, cool. So, we are back to where we initially left off, which is good because that means we didn't break any of our views or anything like that, right? I could still select the different objects. All our raycast hits still work. So we haven't broken anything there. What we need to do now is go to testbed main and go to our world camera, and we are going to put in a temporary camera world camera 2. I'm going to put in a second camera, right? And camera system acquire. So we're basically going to take this logic here, put it down here, copy of it, right? We'll also say to do temp test, right? And we're going to call this one world 2. And I think what I'm going to do is I'll keep it how do I want to do this? I'm going to guess on this one in terms of what how it should work, right? Or where it should be positioned, I should say. So the X, I'm going to change the X and the Z, but leave the Y alone. So the X, I'm going to move to -16. And actually, I'm going to leave the Z alone, right? So I'm just going to shift it. I want to shift it on the X-axis. Let's shift it on the... Let's shift it actually on the... Yeah, I want to shift it on the X-axis, I think. I might get this wrong. We'll see. And I'm going to rotate this plus 90 degrees. And we're going to switch this to world camera 2, world camera 2. And of course, switch this one to world camera 2. All right, and then we'll do we'll do, yeah, render. And where we're changing over this view packet, we're also going to change the isn't this render view packet. So I should be able to say view packet, view matrix equals camera view get. And then we want to say state world camera 2. And I thought we were passing right. I think all we have to do is override the view packet for that. Or the view matrix in the packet, rather. Which, obviously, this is not going to be the way you're going to want to do it all the time, right? Like, you're typically not going to be reusing views like this. But I think, for this hack, that should do it. Really, all we want to see here is that we are actually doing the thing twice with 2 different cameras, right? Okay, so it looks like my rotations were a little bit off there, right? But what did I change in terms of the... Oh, I changed the Y rotation. Well, the Y, yeah, actually the Y rotation should have been maybe minus. Joe, thank you so much for the follow. I appreciate it. Welcome. Let's see. So acquire. This maybe needs to be minus. I wasn't sure about that. And in fact, I'm still actually not sure about it. That's a little better anyway. Looks like we got stuck into the terrain just because of kind of where we set the camera. So our camera is actually going to be like back this way somewhere. And the way that we can prove that is I can just select this car and move it back that way. And it should at some point come into view. There it is. Right, so our camera's just under the terrain is all that means. And I don't really have a way to move that just yet, right? But one thing that I can do, if you'll notice, and maybe I'll change the camera angle to like a better position. In fact, let me do that real quick so that you guys can actually see what I'm on about. So let's just make a note here of, oh, because that's clearing funny, I actually can't read that. I still have the position, but I can't get the rotation. All right, so let's set this to negative 17.64. 2207 and 30 89, right? And then our rotation, we'll probably just keep that at the 51, right? In fact, yeah, it's pretty much bang on where it is. I think we're probably going to need to move this probably to 40 degrees negative, I'm thinking. So let me rebuild this real quick and launch. Am I facing the wrong way? I probably am. Yeah. So if that's 51, what is facing? Oh, it should be negative 51. This will make sense in a second as to what I'm actually doing. Because I want to actually show you guys something. Okay, here we go. That's good enough, right? So, what we can do with this is we can actually say, have a look at how our frustum culling is working, right? This is a way for us to prove it. So our frustum culling is actually tied to this viewport here. This viewport here does not have any such thing, right? It's actually rendering everything as if the frustum was generated by this camera, right? We're not modifying it. So as I move away or rotate this away, you'll see that the car disappears because we're no longer rendering that, right? Because it's no longer in view, it's getting called. And if I go a little bit further, you'll note that the whole sponza goes away too. So that is a kind of a cool way for us to be able to tell that all of our stuff is working as you might expect. So the other thing is we can actually watch our raycast happening in real time, right? So if I move the camera right? We can actually see the origin of where those things are coming from, right? So if I go, I don't know, maybe here, we can actually see those things going out into space from the camera, from afar, right? So that is pretty cool. We actually have multiple cameras and multiple viewports working now. So that is a check. And we have ads coming up in just a moment. So I'm going to pause the stream for that until the ads are done, and I will be right back. Got another 45 seconds on ads. Fifteen seconds. All right, and ads are over. Rushay, thank you for the stretch. Redeem. I do kind of need that, actually. So thank you for that. JP, thank you so much for the follow. I appreciate that. Side code, welcome first off. First time chat, welcome. I saw a view packet in your code earlier. What do you consider a packet? So the way that our renderer works, or our application lifecycle works for a single frame, right, is we have this concept of views. And views can represent a number of things within the engine. One second, I have to blow my nose, sorry. So we have a number of views in the system that are responsible for rendering different things. So one example of a view is our world view that is responsible for rendering the world. Another view that we have is our UI view that's responsible for generating and rendering the UI. Another example might be a mini map, or maybe an editor view, something like that, right? So yeah, so we have a you're familiar with views, command buffers, render targets, right? So essentially a view is one or more render passes, and everything that is encompassed within those render passes. So when I talk about a view packet, what we do is during the sort of application update loop, we gather up all the data that the renderer is going to need to render that particular view. So for each view, we have a structure that gets filled out. And in fact, what I could do is show you. Let's see. So, right, let's look at this guy, right? So we have this structure that gets filled out, and this is filled with information that the renderer will actually need, like our geometry data, our matrices, that kind of thing, to render a particular view. and the geometries have information that links it all to the back end. And so we basically gather all that stuff up at once and then throw it all over to the renderer and say, render this, right? And that's just sort of our way of not having the renderer know about necessarily the components or whatever it's trying to render. The renderer only cares about geometry, for example. So you'll notice that we have this structure called geometry render data, which has different types of geometries, but they're all ultimately geometries, right? And so this structure has changed over time, right? But essentially a render view packet is gathering up all the data that is renderer specific, that only, it's only the data that the renderer actually needs to know about. So we're not passing over components to the renderer and things like that. And then it basically, per frame, per view, data chunk. Yep, exactly. So it's an architecture I'm trying out. So far, it's been pretty successful, I would say. And eventually, my goal with the view system is to actually jobify it and multi-thread it, so that we can sort of go wide, gather up a whole bunch of view packets from different views, because we're going to have eventually tons of different views, right? Like any sort of render to texture is going to be a view, right? So we'll have tons of different views out there that all get basically generated at the same time. And then we'll bring all those packets together and shove them over the renderer, which can also be multi-threaded because it's Vulkan in this case. And so, yeah, that's the ultimate goal here. But we're starting simple, right? So, I hope that made sense. Speaking of the renderer is essentially itself a plugin. So, if we look here, basic layout of the project is we have the engine that contains, it's just a shared library that contains the core engine code. We have a testbed, that's our application that consumes the engine right now. We also have a testbed library, which is a shared library that the testbed uses. So the application itself is extremely light. It only has just this entry point, basically, that loads a few function pointers, and that's about it. And it loads those function pointers out of this testbed lib, right? And this testbed lib is hot reloadable. So as we're writing our gameplay code, we can actually make changes to it, compile just that library, and it'll hot reload, right? And so that's the basic flow. We have some tests and tools, but the big boy is this Vulkan renderer is actually a plugin. So the application can actually tell the engine to use a various plugin, right? And in this case, we only have one renderer plugin. That's a Vulkan plugin. But all the Vulkan logic is actually within this plugin, nowhere else in the engine. We'll eventually have an OpenGL plugin, a DirectX plugin, a Metal plugin, things like that. And it'll be up to the application to just say, hey, what platform are we on? What plugin do we want to use or support? Load that one up and do the thing. And that way the engine doesn't have to care about any of that stuff. Hope that makes sense. So I'm decoupling the render API from both the engine and the app. Yep, exactly. Yep. And it's been pretty successful so far. When I started, it wasn't that way, and I actually had the idea probably about halfway into the series to split that out. Because initially what I was basically going to do was if-def it and just have different builds. But then I'm like, wait, why am I doing that? I could just dynamically load whichever plugin we want to use, right? And I'm thinking, if I do it right, I might be able to hot swap those and maybe have the engine handle that at some point. We'll see. That's a stretch goal, I'll call it. And so the point we're at now is we haven't been focusing on like hyperrealism or any of that stuff. We've been just focusing on getting our core engine components stood up and running so that we can actually build something with it. Because there's a whole heck of a lot more to a game engine than just a renderer, right? So the renderer is definitely an important part of it, but our sole focus hasn't been on that. So right now we have a Phong lighting model. We're going to be switching over to PBR, but we're technically going to support both, right? Yeah, so that's where we're at. Hope all that makes sense. So the point we're at now is basically just the ability to render multiple viewports at once, right? And be able to, select and move around and have them, do the thing. So this is sort of the precursor to an editor application that we're going to build. And the editor itself is going to need this stuff. So our test bed is sort of where we add new features and we just kind of hard code stuff to just get things working and test those features and turn them on and off as necessary. And then we're going to be standing up and scaffolding an editor here shortly, probably in the next stream or two, I'm thinking. And we're going to actually start building out a proper, at least for right now, level editor, right? Love me some BDRFs, yeah. Or BRDFs. Dyslexia is hitting hard today. Anyway, so we just got multiple cameras working with the views. There was one more thing that I wanted to do before we move on, and that is to fix a minor defect that I found in the material system. So, in the material system, when we are... which function was that we are passing all that stuff here? So when we're applying the globals, and I don't remember, I think this is the only one that's doing it, we're passing the renderer frame number and the renderer draw index, which is basically that viewport draw index. And we're passing, let's see, projection, view position. Like half of this stuff is actually in the frame data. And so my thought there is that we should be just using the frame data instead. I don't think any of our other methods here are using it. No. So I'm going to go ahead and type def a struct, and I'm going to call it frame data, because I don't want to... Oops. I don't want to type def it. What am I doing? I just want to forward declare it. And then come down here, and instead of passing these two, we're going to do struct frame data p frame data, right? And then these two guys can go away. P frame data, a pointer to the current frames data. Wow, I cannot type tonight. What is going on? All right, and then we don't need the draw index anymore. And then if we go to material system C, apply global, we can frame data, p frame data, right, whoops, that should be a pointer. We'll also need to include that up here. So include, oops, core frame data .h. I think that's where it is. And frame, oops, p frame data. What happened to my IntelliSense? Renderer frame number, I think is what I called it. And then it should be p frame data draw index, I think called it. Well, we also need to update that down here. So this is just p frame data. Okay, I think that is all we need to do for that. Whoops. Why did you do that? Build. Okay, so... Oh, right. The views need to be updated for that. So the render view world, I think, is the only thing that's using it. Looks like it, yeah. Okay. Let's see, 416. So this is going to just be p-frame data now. What? Oh, is it constant? I'll bet it is, isn't it? Did we actually modify that in here? I don't think we do. Let's see. Make that constant, and then we should be good. Oh, missed another one. Let's see. 463. Oh, right. Okay. It's just the same thing. Now the UI needs it. Okay. View UI. Let's see. Just delete these guys. Okay. So I think that's it. Just make sure it runs. I didn't break anything. Yeah, I think we're good. Okay, cool. All right, so that is pretty much it in terms of what I wanted to accomplish for that tonight. So the next thing that we're going to move on to, should have left this running, is we actually want to build a wireframe view, right, where we render these things in wireframe. And so basically what I want to wind up with here is this will be just sort of a regular view, and then this will be a wireframe view. And what a lot of people will do, and I've seen this in a lot of tutorials and things when they're showing like a wireframe view, is they'll sort of just render the same scene. They'll just flip the mode to wireframe. But that still pulls all the texture sampling, all the lighting, all that other stuff, and you really don't need to be doing that, right? Like, really all you needed to be doing is just drawing all the individual wireframes in like one shade, right? Or maybe a couple different shades for different object types or something like that. And so I think what the goal is going to be here is to implement that using just a flat color of some sort, and then maybe a different color for the currently selected object, right? And I think that is probably the best and easiest way to do it. So we're going to make this guy our wireframe view, and then once we have that, essentially going from a perspective view like this to an orthographic view is going to be trivial, because all we have to do is just modify the viewport that is drawing it to use that type of projection matrix, and we're good. So that's what we're going to do next. However, I want to go ahead and commit what we have. Let me just do a quick check on what I'm pushing here.
So it's not a whole heck of a lot of code. It's mostly just kind of moving things around and adding or removing parameters, right? So I'm going to add this as one commit. That way the commit history is there, and you guys can see everything that I'm doing here. And then we'll go ahead and probably kick off a branch for the wireframe stuff. Okay, yeah, that all looks good. Let's see. So we're gonna call this fixed camera acquire issues. Added multi camera support to views. Fixed material system to use frame data instead of passing frame numbers. Draw indices separately. Okay. And I'm just going to push this straight to master. Whatever, it's not the end of the world, right? Allergies or a cold. I certainly hope it's just allergies. I've been getting my butt kicked by it for half of the day. But my allergies are really bad. I actually have to take 2 different types of allergy medications every day just to keep it under control, but it doesn't always work. So, yeah, getting my butt kicked by it, for sure. I might have to take some Benadryl and just, like, go pass out in a coma, right? Yeah, I hope it's just allergies, too. Hope I'm not getting sick. That would be really lame. But, you know, it is what it is, I guess. But yeah, I mean, it doesn't help that I have 4 animals in the house and I'm allergic to every single one of them. That doesn't really help. I'm not a smart man sometimes. But yeah, hopefully it's just allergies. Anyway, so this is all up, pushed to main so that you can access it really quickly. I will mention that we actually have a website that is sort of the central hub for all this stuff, right? So we have a kohiengine.com. Okay, Chrome, why have you positioned yourself this way? There we go. So we have a kohiengine.com where it's basically sort of the central portal for all this. So we've got the Twitch link. All of this stuff gets archived on YouTube as well. And then we also have links to like the repo and the Discord server here. So you can click those things and check those out as well. So all of the stuff that I just pushed is available here. All of this is completely open source, so you guys can access it. As soon as I finish up doing something here, I push it up so that you guys actually have access. So just figured I'd point that out really quick. You know the struggle, you have 6 cats. I would die if I had 6 cats. I have 2 cats and 2 dogs, and that is enough. I think it's actually too much. Yeah. Like I said, I'm allergic to them all, but if it was 6 cats, I'm way more allergic to cats than dogs. It'll blow my nose again, I'm sorry. Okay. You're very thankful you're not allergic. Yeah, definitely. I wish I wasn't too, and it seems to only get worse as I'm getting older. Yeah, I love all of my animals too. You know, I definitely love them. There's one of the cats over there sleeping, and my old dog is over there passed out in the other corner. I should eventually probably get a pet cam, but I don't know. Maybe I can get this one. Do I have enough slack on this one? Let me see. So that's my old boy right there. So he's definitely my old boy. He's about 14, so he's just passed out. And the other cat isn't quite within range. My older cat isn't quite within range where I can get a decent shot of her, but she's like 11, so yeah, he's totally passed out. And it doesn't help that he's also completely deaf now. His bark is super, super loud, and so I suspect that given his old age, he's just kind of barked himself deaf, literally. And yeah, he hears absolutely nothing now, so he sleeps completely soundly. Like, in some ways, I'm kind of jealous how soundly he sleeps, but that's a steep price to pay for sound sleep, I guess, right? Yeah, poor guy. I know, I feel bad for him, but he still runs around on occasion and plays and stuff, so my hat's off to him, you know? He's 14, like I said, so. All right, so I guess let's go ahead and create a branch here. So I'll say get what do I want to call this? Feature wireframe, I guess. That's what we'll go with. All right, so really the only thing we have to do to enable wireframe is just basically flip a switch on our graphics pipeline, right? But I want to take a look real quick at the shaders we have available. So we do have a color 3D shader. But that takes a pretty specific layout of just position and color, right? And right now our geometry actually has a lot more than that. So if we look at our material shader, our geometry is supplying all of these things. So what I'm thinking is I probably might need I really ought to make the geometry so that we can like split up what gets sent to the GPU, but I don't have that right now, and I don't know if I want to build that in. So my initial thought is I'm just going to make a new shader that just takes this stuff and acts exactly the same as the color 3D shader, and we just pass in a single color to render everything as and call it good. The color 3D shader also acts a little bit differently in the terms that the color is passed as per vertex, right? Which we also don't necessarily want to do. So really all we need to do is create a new shader, I think, that's going to take these things, although it's only really going to ever use position, and then we'll also have a uniform for color, and we'll call it a day at that, right? I think that's probably going to be the simplest and lowest barrier to entry. If you keep layout locations consistent across your shaders, you can make a simple vertex format that only supplies the required locations. That is the ultimate goal. And the other thing I actually want to do is I actually want to make a sort of reflection where we can actually examine the shader. Because right now we also have to write these shader config files that give sort of the layout. So that's the ultimate goal. But we're not there yet. But yeah, ideally, I would much prefer to do it that way. I think now, for the simplicity of just getting it in there, I think I'm just going to do it the hacky way, right? Okay. We got ads coming up in a minute. So I guess I will go ahead and just start creating files. You guys don't need to watch me do that. And then we will be... Yeah, it's not even hacky. It's a work in progress. That's true. Yeah. You know, there's to-dos all over the place, of course. So that's a good point. Okay. Ads. So for those of you that can still actually hear me, I'm just going to create the files while we wait. So got about 35 seconds on ads. All right, and we're done with ads. So let me just finish this one edit, and we'll kind of go over what we're going to do here. All right. So we have a couple new files, and I'll just show them in the tree because it's a little easier to digest that way. So we have a new shader config. We're going to call this the wireframe shader, right? So it's going to be one of our built-in shaders. And we have two new GLSL files. So one for the fragment and one for the vertex, right? So I'm going to set up the shader config first, and then I will edit the shader files to actually match that, right? So the vertex shader is actually just a copy of the material shader, and the fragment shader is a copy of the color shader, because it's pretty much like 90% of the way that I want those to work. So let's see. Do we want depth testing? Do we care about depth testing in wireframe? I'll say yes for right now. I'm not 100% sure. Topology, we're just going to stick with triangle list. We're going to use the rendering mode to do away with that. So we're just going to use triangle list for the topology type. The attributes, I'm actually going to have to grab from the material config. So wait, what was I editing then? Did I edit the wrong file? I did. Perfect. I want to edit this one. I was going to say that looked weird. Okay, so this is going to be wireframe. Our render pass is also going to be wireframe. We're going to call this the wireframe shader. wireframe shader. We are going to depth test and write for now. I'm not 100% sure we're going to want to do that going forward, but for now, we'll go ahead and do it. Our attributes are fine. We need projection view. Should I use ambient color as like the backdrop color? No, I'm not going to do that. View position. I can't see why we care about that. Mode, we don't care about that. We don't need any texture lookups. We don't need directional lights, point lights. I'm not 100% sure if we're going to need a property structure. I don't think we're going to. We don't need this guy. This is probably just going to be a vec for local, and we're just going to pass color here, I think. So we're not going to bother using the vertex color. We're just going to basically use a flat color that we pass in per object. That will allow us to change the wireframe per object, or change the color of the wireframe per object. So like if it's selected, or we want to use a different wireframe color for terrain versus a static mesh or something like that, we can do that. But I think that's going to be pretty much all we need to do. Blocking the ads for you. Yeah, I'm trying to, I try to pause the stream whenever ads come up so that you guys don't miss anything. Hopefully that is helpful, right? I saw that being done on another stream and thought that it was, you know, kind of useful, so. All right, let's look at our vertex shader first for our wireframe. So we have all of our attributes. We don't need those. We just need projection of view for our globals. Our push constant is going to be a model matrix like always. Our data transfer object is just actually going to have color in it. So we don't need any of the rest of that stuff. We do have one uniform that we need. And I actually don't see, do we not have a, we don't have a local, or I'm sorry, instance uniform object. So we'll do layout, set, this is going to be set 1, binding 0. This is going to be a uniform, and we're going to call this the instance uniform object. And all this is going to contain is a vector for color. K-99, thank you so much for the follow. I appreciate it. So we're basically just going to use that color as the color for everything, right? Comma21, thank you for the follow. I appreciate it. I apologize to you guys, by the way, for my stuffiness. I'm sort of in the middle of an allergy attack, or at least I think / hope it's allergies and not like me getting sick. But yeah, my sinuses are complete rubbish at the moment. Okay, so we don't need this. Our DTO color is going to be our, oh, I didn't name this thing, did I? This needs to be instance UBO. So this is going to be instance UBO dot color. We don't need that. We don't need, actually we don't need any of this stuff, right? All we need to do is just calculate the position as we always do, using the projection view and model. And we don't actually even need the mode, right? So this is a super, super simple shader. I think I've got all of this right. Okay. So we'll go ahead and do an edit on the fragment shader, which is super simple. So our data transfer object just has color, and we're just going to write that out, right? And actually, I don't think there's anything. Yeah, we don't even have to change this. We can use it as is. So that's super simple. Let's see. Lisp Gamer, is it worth going back to support OpenGL these days? I haven't made that decision yet. I think out of all the rendering APIs, that would probably be the easiest one to add, quite honestly. But yeah, I mean, maybe. In Germany, we say, I feel like I'm gonna butcher this. Is it gut Besserung? Besserung, maybe. Get well soon. How are you? Cool stream, by the way. Thank you for that. I appreciate that. Yeah. Like I said, hopefully it's not me getting sick, and hopefully it's just allergies. I have really terrible allergies. I have 4 animals in the house, and I'm allergic to every single one of them. So that's pretty cool. Not very smart of me, probably, but you know, I love them. So. Let's see. Can't Direct3D Metal be handled by some of the open source abstractions? Yes, they could be. However, part of the point of this stream / engine development is as an educational resource. So the idea here is to watch the process of an engine being put together from scratch. And this is just one way of doing it, right? So, you know, we don't use any third-party libraries with 2 exceptions. And those are, let me close this. Those are temporary. So in the engine, we use stb image to load image files for our textures, and we use stb TrueType to load fonts. And in both of these cases, we're going to be moving these out of the core engine and into an external tool set. Because we're going to have our own binary format for both of these. So at some point, even the engine won't be including these things. But these were included just because I didn't really see the value in re-rolling these 2 things. They're kind of a solved problem, and I didn't think it would add a lot of value to the project. So, but if we want, we could write our own parsers for those things as well, right? But otherwise, we've done everything here from scratch. We do it live, yes. So yeah, I mean this series did start off as sort of a YouTube kind of tutorial series, and then it's kind of morphed from there to this. So yeah, all this stuff is all the history of this is all available on my YouTube channel, which I'll throw a link there in chat for you guys. Anyway, so now we have our shaders set up. We need to go to post build. And we need to add these shaders to our build process. Not gonna lie, this sucks. I really want to fix this. And instead of having to add manually these here every single time, I'm not happy about that. But priority-wise, it just hasn't made the cut, right? Shader. So this is wireframe shader, right? So that's just our build process that we use we've got our own sort of tool that builds the shaders for us. And all we do is we just basically pass this through. It parses out what type of shader it is from the file name, and just builds it into the Spurvy shader, right? So we've got that. I also need to, for you Windows guys, update the batch file. Because of course Windows has to be different. Of course it does. So we'll do wireframe shader. Wireframe shader. Okay. So now our post build should work. Okay. So you can see here that we get the SPV files for that. So if we go back and look at our assets here under shaders, expand this guy out, we now have our SPV compiled SPV shaders, right? So we have that in place. All right, so we can get rid of that. Windows, yeah, I agree. Nightloan, thank you for coming by to say hi. Appreciate it. Yeah, in case you guys haven't realized this, I am on Linux at the moment, but more a Mac man these days, unless it's servers. Yeah, I feel that. I mean, we do support all 3 platforms, so I actually have a MacBook here that I use for testing. And so we do run on all 3 major desktop environments, right? That was a goal from the very start. The only one we didn't support right out the bat was Mac because I didn't have one, but I was able to purchase one from the proceeds of the channel. So now we officially support all of those. Anyhow, time to disappear again. All right, Nightloan, see ya. Thank you for stopping by. Appreciate it. I use Windows with WSL2. It's pretty cool. Yeah, I mean, WSL, if you can't use Linux, WSL is the next best thing, right? It's pretty awesome. I did it for a number of years when I was forced to use Windows. Now my current job, my work machine is a Mac. So thankfully I can just work in the terminal for that as well. If there was a like button, I'd hit it. Yeah, the closest thing is like follow, I guess. Anyway, so we have this hooked up. Let's see, should we do this as a different view? I'm thinking we probably should. But it's going to be a view that's going to be very similar to the world view. So I'm wondering if we should just maybe pass in some sort of flag or something to render it wireframe instead. How do I want to do this? Because we have a lot of things going on in here, right? We have... Well, see, this has got stuff we don't need too, though. Like the skybox stuff, we don't need to render that for a wireframe view. Really, all we need is like this, but like minus all the material stuff. I think I'm just gonna do a different view. I think that's gonna be the easiest way to do it. And then we're just gonna have very similar loops to actually go through and draw all this stuff. But I think that's fine. I kind of like my Mac, 64 gigabytes of RAM, 8 terabyte SSD, and a workday battery life is kind of crazy. Yeah, exactly. The batteries on these things are nuts. I've noticed that same thing too. So I did go for the 64 gigs of RAM on this one. This is an M1 Mac. I did go for the 64 gigs of RAM. I went for a smaller amount of drive space. I just went for 1 terabyte because I have a local file server here that I can back my stuff up to. And so if I wind up having like tons and tons of stuff, I can just offload to that. So I didn't need to spend a lot of extra money, because upgrading the hard drives in these things was ridiculously expensive from one level to the next. So I was just like, yeah, I'm not going to do that. I just got the 1 terabyte. May I ask, what do you think of Rust Lang? I have not used it enough to have an opinion, frankly. I used it a little bit. They're doing some interesting stuff with the borrow checker and all that, but I will say that I don't like the compiler telling me how to manage my memory. That's one of the reasons I use C and not C++, with all of its shared pointers and all that garbage. I don't use any of that stuff, right? I want to handle the memory myself. But yeah, I haven't used Rust enough to say one way or the other. Sorry. All right, so I think what we'll do is we'll probably go ahead and stand up a new view. Yeah, we'll go ahead and stand up a new view. At least we'll start scaffolding it. I don't think we're going to get through it tonight in 9 minutes, obviously, but we can at least start on it. So let's go ahead and let's do testbed lib. Whoops, testbed lib. Source. Did we put that under views? Maybe this should be under editor though. Yeah, I think I'm gonna put this under editor. And then yeah, we'll put it here. So let's create a new one, and we'll call this render view wireframe.h. And we'll open that one, and then we'll also go to world.h, and we're actually just going to, I think I'm gonna do just one of these. And I'm also going to start getting rid of these pragma ones and go back to standard include guards. So just so that we're a little bit more standard. So if not defined testbed render view wireframe H, whoops, or G, that's fine too apparently. Then we want to define wireframe H, and then end if down here. All right, so we have that. We just need to basically do how do I want to do? Yeah, we can simplify the render world data as well. Okay, let's do what is the, so we'll do view world, and we'll replace that with view wireframe. I think that looks correct. Okay. Thank you for the stretch redeem. Appreciate that. Can use that at the moment for sure. All right. So in terms of our data, we don't need skybox data. We need world geometries. We need terrain geometries. We are not going to be rendering anything. Actually, I take that back. We might render debug geometries. I'm going to leave that there for right now. Okay. Why do we have this linear allocator forward declared? That's in frame data now. Don't need that. Okay. So we'll take these. We'll go add render view wireframe.c. Found include. God, I can't type. All right. Render view wireframe.h. Paste all these guys in. Right. Let's see. Why does it... Alright. It's gonna make me do it the hard way, I guess. Okay. So, essentially we're just going to be filling this out with stuff that looks very similar to the editor world, but... let's see. No real reason why you can't write C in C++. Except for the fact I have to use the C++ compiler to do that. Not to mention that the C++ compiler also garbles the output of stuff, so you have to extern C a lot of things in order to get a clean interface to be able to load and hot reload stuff. I wrote a kind of video editor player. The editor was written with smart pointers, made it really robust and pretty quick to write. The player was 0 runtime allocations, massively threaded, and written in more of a C style, but the whole project was C++. Nice. Yeah, yeah, C++ Bengals, exactly. Yeah, I mean, the thing is, like, a video player has to be performant to some degree, but it doesn't have to be as performant as, like, a game engine has to be, right? You were born in 2001 and you prefer audio caffeine too, yeah. Yeah, I like my audio caffeine, you know. Metalcore gets me going, for sure. Okay. So, I think this is probably where I'm going to end the stream tonight, just because we're not going to get this view implemented in the next, like, 3 minutes or anything, right? So, I do have to get up and go to work in the morning, assuming that I'm not actually getting sick. I don't think I am, but we'll see. So I think this is where I'm going to end it. So again, if you're new here to the stream and you haven't already, I would appreciate a follow. It helps me out a lot. If you want more information on this, we do have a website, which is kohiengine.com. It has links to the... Well, actually, I'll just bring it up real quick. Actually, I'll bring it up real fast. So it has a couple things on here. Basically, links to the YouTube and Twitch. It has link to the GitHub, Patreon, Discord, that kind of stuff. We also have automated API documentation. So this stuff is auto-generated every time. For some reason, it's not loading, so that must have broken. Nice. But basically, this is every time I push to main, this updates. In fact, I just pushed to update an update not too long ago, so it may still actually be running. But we do have automated API documentation available as well. And so, yeah, I would encourage you guys to check this out, join the Discord. I think our Discord's at like around 600 people at the moment. So there's always people on there that are talking about this and plenty of other stuff as well. So there's that. All of these streams are also archived on the YouTube channel, so there is a link to that. And yeah, I think that's probably about going to do it for tonight. So let me see who's online that can be rated. Let's see. I'm going to raid Pirate Software because Thor is awesome, and I think he's playing a game at the moment, but yeah, I'm going to go ahead and raid him because he is an awesome game developer. If you guys aren't aware of who he is, he's making a non-traditional RPG called Heartbound, and that's actually the soundtrack that is playing in the background on this channel because he's given me permission to use it. And so I highly encourage you guys check out his stream as well. So I'm going to go ahead and kick off that raid. And thank you guys so much for joining me here tonight and following along and interacting. I really appreciate it. It's great talking with you guys, and great to have you here. And thank you for putting up with my sniffly self tonight. I know my voice is probably annoying to listen to tonight, but anyway, thank you guys, and I will see you guys next time. Peace.